Hi everyone, I am Dr.T. Srinivas, Assistant Professor of Mathematics. Today we will learn higher order non-homogeneous linear differential equations. Particularly in this topic, we learn about higher order non-homogeneous linear differential equations with the constant coefficients. The general form of non-homogeneous linear differential equation of order n with constant coefficient is an d power ny by dx power n plus an minus 1 d power n minus 1y by dx power n minus 1 plus dash plus a1 into dy by dx plus a0 into y equal q of x. That is equation number 1. Here an is not equal to 0 because nth order. So an minus 1 dash up to a1 comma a0 are constants. These are constants. And q of x is a function of x. Q of x is a function of x. Let the solution of the equation 1, that is y equal yc plus yp. The solution y equal yc plus yp is the solution of the equation 1, is a solution of the equation 1. Here yc is called complementary function. Yc is called complementary function. It is also the solution of the homogeneous linear differential equation of order n with constant coefficients of the equation 1. Yp is called particular integral or particular solution of the equation 1. Yc is called complementary function of the equation 1 and yp is particular integral or particular solution of the equation 1. Here q of x has various forms, that is particularly x power k, b into e power ax, b sin ax, b cos ax, or finite combinations of these. Q of x has various forms, particularly x power k or b into e power ax, b sin ax, b cos ax, or finite combinations of these. Differential operator. The differential operator d can be defined as d power 0 into y equal to y, d power 1 into y equal to dy by dx, d square y equal to d square y by dx square, dash d power ny can be written as d power n y by dx power n. So here the d is called differential operator. Now the equation 1 becomes, by using the above concept, an d power n y plus an minus 1 d power n minus 1 y plus dash a1 into d plus a0 into y equal q of x. This can be written as an d power n, an minus 1 d power n minus 1, a1 into d plus a0 into y equal q of x. Say this term is equal to p of d. So p of d into y equal q of x. Here p of d equal an d power n plus an minus 1 d power n minus 1 dash a1 into d plus a0 is called polynomial operator of degree n. So therefore the general form of non-homogeneous linear differential equation of order n with the constant coefficients is P of d into y equal Q of x. Here P of d equal an into d power n plus an minus 1 d power n minus 1 plus dash a1 into d plus a naught. This is the general form. If d is the differential operator, then 1 by d is integrable operator. Integrable operator. D is differential operator, then 1 by d is integrable operator. What is the particular integral? How to define? If P of dy equal Q of x, then particular integral is yp equal 1 by P of d into Q of x. This is the particular integral. Properties. P of d of by1 plus cy2 can be written as b into P of d y1 plus c into P of d y2. Here b comma c are constants, y1 and y2 are both are nth order differential functions. Second property, p1 of d plus p2 of d into y equal p1 of dy plus p2 of dy. Third property, p1 of d into p2 of d of y equal p1 of d of p2 of dy. Associative property, p1 of d of p2 of d into p3 of d equal, it can be written as p1 of d into p2 of d into p3 of d. Distributive property, p1 of d of p2 of d plus p3 of d can be written as p1 of d plus p2 of d plus p1 of d into p3 of d. This is the distributive property. That means polynomial operators satisfy the linearity property, commutative property, distributive property and associative property. And one more property, exponential shift property. Exponential shift property. If P of d is a polynomial operator and f of x is a function of x, then how to define? P of d of e power ax f of x. E power x, move the left side, then d replace it. E power ax of P of d plus a f of x for any constant a. Now, using the above formula, it can be written as d minus a whole power n e power ax f of x equal. So, e power ax outside. In place of d plus a. D minus a plus a. So, d. E power x d power n f of x. D minus a whole power n e power ax f of x. By using the shift operator property, this can be written as d minus a plus a whole power n f of x. So that is e power ax, d minus a minus a plus a will be cancelled, d power n f of x by using the above property. In the same manner, another property, P of d c e power ax can be written as c e power ax into P of a. Now, in this topic, we discuss the particular integral methods when q of x equal. The first method, q of x equal b e power ax. Here a comma b are constant. Second method, q of x b into x power k with k greater than 0 is an integer, that means positive integer. Third one, q of x equal b sin ax or b cos ax. Here also a comma b are constants. Fourth one, q of x equal e power ax into v. Here v is the function of x and a is the constant. And the fifth method, q of x equal xv, where v is a function of x. In this topic, we discuss these methods. Thank you.